Hello everyone, good day. My name is Hannah Jean Aviso from BSA1C, and now we will going to discuss the transformations and translations for chapter 7. Okay, so we have two main topics here. We have transformation and translation. First is transformation. Transformations describe sizes, positions, and orientations of shapes such as flips, turns, slides, and scaling. To transform something is to change it. In geometry, there are specific ways to describe how a figure is changed. The transformations include translations, rotations, reflections, dilation, or enlargement. So when we say transformation, sinasabi dito na to transform something is to change it. So dapat sa transformation na makikita natin is merong mga changes. Whether nga it's a flip or ito-turn natin siya or i-slide into another direction. So ngayon, sabi rin dito na the transformations include translations, rotations, reflections, and etc. So, ang mako-cover lang ng aking lesson for today is translations. Next is we have performing transformations. When we say pre-image, the initial object you start with is called the pre-image, while the image is the final object after all the transformation has been made. So, pre-image, yung pinaka-original na object na ginagamit natin na wala pang transformations na ginagawa, while the image is yung final output na ng ating ginawang transformation. Okay, so rigid transformation. Any transformation that does not change the size of the object is a rigid transformation. This includes rotations, translations, and reflections. A transformation that changes the size of the object, like a dilation, is called a non-rigid transformation. So, sinasabi dito na kapag sinabi nating rigid transformation, meron siyang transformation na nagaganap pero hindi nagbabago yung size ng object. So, for example, sa rotations, di ba niro-rotate lang natin siya, hindi naman nagbabago yung size. Sa translation, minomove lang natin siya into different direction. Sa reflection, nire-reflect lang niya yung object na meron tayo. So, even though may transformations na nagaganap, hindi nagbabago yung size ng object. Kapag sinabi namang non-rigid transformation, dito na yung transformation that involves the change in size of the object. So, for example, yung dilation nga, di ba ang dilation, pinapaliit niya yung isang object. So, syempre, kung ganun yung transformation na nangyari is, magbabago talaga yung size ng object na ginagamit natin or ginagawa natin ng transformation. Next is renaming transformations. It is a common practice to name a shape using capital letters of the English alphabet. For example, the square below is named ABCD. It is also a common practice to name transform shapes using the same letter with a prime symbol. So, sinasabi dito na kapag nagre-rename daw tayo ng mga shapes is gumagamit tayo ng capital letters from the English alphabet. And kapag once na-transform na natin yung shapes na yon is mababago rin yung name niya. Malalagyan na siya ng tinatawag nating prime symbols. So, let's check ano nga ba yung itsura kapag naka-rename na tayo ng ating shape or object. Here is the example of renaming transformations. So, sa first one, makikita natin is meron tayong square. So, we have corners A, B, C, and D. Excuse me. So, this is called shaped ABCD. While here, ito na yung transformed natin. So, we have A with the prime symbol. Yan yung nag-i-indicate na transformed or tapos na yung transformations sa phase natin na ito. So, meron din tayo dito sa C, sa D, and sa B. So, mamaya, papakita ko siya na nasa graph. So, ngayon, pinakita ko lang kung paano tayo nagre-rename ng transformations. So, next is translation. So, di ba sabi natin kanina, transformations includes translations, reflections, etc. So here, a translation occurs when a figure is moved from one location to another without changing its size, shape, or orientation. A translation slides an object a fixed distance in a given direction. The original object and its translation face the same direction just like the figure below. So when we say translations is nililipat lang natin yung figure into another location without changing its size. So this is called rigid transformation, right? Kasi hindi nababago yung size na meron tayo. Okay. Ah, yeah, hindi nababago yung size na meron. So, sabi rin dito, the original object and its translation face the same direction, just like the figure below. So, here is the example. Ayan. So, let's examine some translation related to coordinate geometry. The example shows how much vertex moves the same distance in the same direction. So here, what are the coordinates for A, B, and C? So we have A, B, and C. So what are the coordinates for A, B, and C? Then what are the coordinates for the transformed A, B, and C? How are they alike? How are they different? So first, ito munang first question yung sagutin natin. What are the coordinates for A, B, and C? So, paano ba tayo humahanap ng coordinates? So, tuturuan ko kayo. So, here, dito sa pahiga is what we call the x-axis. Yung pataas is y-axis. So, hanapin lang natin si A. Nasaan ba si A? So, here, ito si A. Itong dot na to. So, titignan lang natin kung saan siya nakapwesto. So, pag tinignan natin sa x-axis, nasa -4. So, yun yung laging una kapag nagsusulat tayo ng coordinates. X and Y. X yung nasa unahan, then yung second number is the y-axis. Then, we have -4 as our x, and then 5 as our y. So, ganun nyo na lang din kunin yung coordinates ni B and C. So, next, what are the coordinates for transformed A or translated A? So, ulit, hanapin natin si A. Pero, dito na tayo sa translated. Dito na tayo sa transformed na siya. So, ano ulit yung kanina natin? -4 and 5. Tingnan natin kung ano yung changes niya. So, we have sa X, 2. And sa y is 5. So, sabi dito, same distance in the same direction. So, same distance, same direction. So, kung ilan yung distance na minove ng C, yun din dapat yung distance ni A. So, yup, ganun lang din natin kukunin yung sa B and C. So, how are they alike? Ano ba yung pagkakapareho pa rin nila? Of course, same sizes pa rin, walang nabago, same orientation, and same everything. Nabago lang siya ng direction, nabago lang siya ng place or lugar kung nasaan siya. And next, how are they different? Yap, kagaya ng sabi ko, nagbago lang yung lugar niya sa mismong graph natin. So, dito, nandito pa siya sa left side, and then nalipat siya into right side. So, magkaibang quadrant na siya nakabilong. Okay, so sabi dito, each vertex slides 6 units to the right. So, paano ba natin malalaman if tama yung So, paano natin mako-confirm if tama yung sinasabi dito na each vertex slides 6 units to the right? So, let's see. 6 units daw. Okay, so let's start. Okay, so let's start with the letter A. Sabi dito, 6 units. So, pwede nating bilangin here. 1, 2, 3, 4, 5, and 6. Tama? 6 units to the right. Next, we have the letter C. 1, 2, 3, 4, 5, and 6. So, na-confirm natin na yung each vertex, they slide 6 units to the right. Tama naman ang direction natin. Left to right. Okay. So next, the general rule is xy is equals to x plus a then y plus b. For example, below, results when rectangle DEFG is translated 4 units right and 8 units up. So, translated daw siya ng 4 units up, pataas, then 8 units, sorry, 4 units right, and then 8 units up. So, from here, ito ang ating pre-image, then this is our image or the final image. So, nag-transform siya from here to here. Okay. So the rectangle has coordinates D, E, F, G. So we have D, ay dito na lang muna. D, E, F, G. Okay, so for letter D, we have coordinates 2 and -9. Paano ba natin isa-solve to? So that sabi dito A and B. So x plus A, y plus B. So 4 units right. Ito ang ating magiging A and ang ating B is 8 units up. So 2 and -9. We have 2 plus 4 and -9 plus 8. So hindi natin ipagsasama yan, magkahiwalay si x and si y. So we have 2 plus 4 is equals to 6. -9 plus 8 is equals to -1. So, kapag na-solve na natin lahat, papalitan lang natin siya, ay hindi, dadagdagan lang natin siya ng plus A and plus B. So, right. Tapos, after nyan, makukuha na natin yung transformed coordinates. So, after solving the translation rule, we just need to graph the new image after all translations. So, after natin makuha yon, igagraph lang natin siya. Ayan na siya. Here, ito na yung image natin, yung final image natin. So that's it for today. Thank you for listening po. Thank you. Bye-bye.
So, perimeter and area. Perimeter is simply the sum of the length of its sides. For example, okay, a rectangular handkerchief is 10 inches long and 4 inches wide. What is its perimeter? So, since perimeter ng rectangle ang given, so we're gonna use the formula 2 times length since yung form ng is like this, di ba? So, this is the length, and this is the width. Since same silang dalawa ng measure, so we're gonna use 2 times length plus, since perimeter, 2 times the width. So, we have 2 times 10 plus 2 times 4. So 2 times 10 is 20 plus 2 times 4 is 8. So the perimeter of the rectangular handkerchief is 28 inches. Okay, so next naman. What is the perimeter of a regular hexagonal dining table with one side measuring 27 and 3/4 inches in length? Okay, so sa given, ang binigay lang is the length, which is the 2 and 4 inches. Since si hexagon is same lang naman ng measurement, yung every side niya. So all we're gonna do is yung length ng side, which is the 27 and 3/4 inches, times 6, since hexagon is has 6 sides. Okay, 27 and 3/4, when it's converted to decimal, it will be 27.75 times 6. Well, this is 6. 6 times 6 is equals to 166.5 inches. And how about naman sa last? So sa last, a right triangular park is situated on the corner of a town. If the length of the sides are 975 feet, 1,200 feet, and 1,546.16 feet, what is the perimeter of the park? So, the park is triangular or triangle. So, all we're gonna need to do is we will just add the measure of the sides of the triangle, which is the 975 plus 1,200 plus 1,546.16, and the answer is 3,721.16 feet. Ganun lang po siya. Basta pag perimeter, yung total lang po, yun lang po yung total ng measurement ng side ng polygon or ng isang polygon. Okay, so next is the area. So yung area naman, ito yung number of square units it takes to fill the interior of the figure. Okay, so example. A rectangular polygon which is 8 by 4 meters has an area of 32 square meters. So, para makuha naman yung area ng isang rectangular polygon, all we need to do is to use the formula, which is area is equals to base times height. So, meaning, times lang natin yung given, which is 8 times 4. Kaya naging 30. And kung square naman yung hahanapan ng area, we're just gonna use the formula area is equals to side square. Since all of the sides of the square is equal naman yung measure ng side. And then, kung triangle naman, ang gagamitin natin is area is equals to 1/2 yung measure ng base times height. Ano lang po. Then, kung trapezoid naman is 1/2 times yung base 1 plus base 2 times height. Ganun lang po. And kung area naman po ng parallelogram, ang gagamitin lang nating formula is simply the area equals base times height. Para lang siyang yung sa rectangular polygon. Ganun lang. And last, yung circle. Okay, before we start, so, ito po pala si radius from the center point to that. Then, pag diameter is from this point up to this point. Kumbaga, dalawang radius na siya. So, kung sa circumference po, ang gamit nating formula is pi times d or 2 pi r, which is the value nga po pala ng pi is 3.14. Sa area po, all we need to use is the formula, this one, pi radius squared, or 3.14 times value ni radius squared. Ganun lang po.
Hello and good day everyone. Now we were going to tackle the volume and surface areas. The volume of a three-dimensional object is the amount of space it occupies. So when we talked about or when we say about volume, yung volume ng mga three-dimensional objects is yung amount ng space na ino-occupy nila. So kapag nag-compute tayo nito is kino-compute natin kung gaano kalaki or ano yung amount ng space na nakukuha ng three-dimensional object na yon. So next, when we talked about surface area, the surface area of a three-dimensional object is the sum of the areas of all its surfaces. So when we say surface area naman, ito na yung pinag-a-add na natin lahat ng areas ng surfaces ng isang three-dimensional object. So makikita tayong mga examples kung saan kailangan nating i-add yung mga areas na yon para makuha yung surface area or yung volume. Next is we have important volume formulas. So we have for the cube, meron tayong for rectangular prism, triangular prism, and a cylinder. So first we have cube. So V or volume is equals to S cube. So, ibig sabihin niyan, i-add natin yung tatlong side ng cube para makuha natin yung volume niya or kung gaano kalaking space yung in-occupy niya. Next is we have the rectangular prism. So, we have the formula V or volume is equals to length times width times height. So, that is for rectangular prism. So triangular prism, we have volume is equals to 1/2 times length times width times height. So that is for triangular prism. So lastly, we have cylinder. V or volume is equals to pi times radius times 2 times height. So here are the examples of cube and rectangular prism. So for the cube, we have find the volume of the cube whose sides measure 3 inches. So, 'di ba sa cube is equal lahat ng sides niya. So, pwedeng kahit isa lang yung given natin, alam natin na ito yung pinakagagamitin natin. So, we have here our cube with 3 inches by each side. So, we have volume is equals to S or sides cube. So, we have 3 inches times 3 inches times 3 inches because cube yung exponent natin. So, in total, we have volume is equals to 27 inches cube. So, next, we have rectangular prism. So, find the volume of the rectangular prism whose length is 5 inches, width is 9 inches, and height is 4 inches. So, we have here our formula. Then, isa-substitute lang natin. So, 5 times 9 times 4 is equals to volume equals 180 inches cube. Next is we have triangular prism. Find the volume of the triangular prism whose length is 6 centimeter, width is 4 cm, and height is 3 cm. So here, meron tayong 1/2 sa formula ng triangular prism. So, hindi dapat mawawala yon. So, volume is equals to 1/2 times 6 times 3 and times 4. So, in total, we have volume is equals to 36 cm cube. Lastly, we have the cylinder. So, find the volume of the cylinder whose height is 3 feet and radius is 4 feet. So, dito, itong una natin sa formula is pi. So, given na yan. So, ang pi natin, ang amount ng pi natin is 3.14. And then, mumultiply natin siya sa radius na 4. 3.14 times 4 times 2 nakasama sa formula. And lastly, the height. So, we have 3.14 times 4 times 2 and times 3. So, for our cylinder, we have volume is equals to 150.72 feet cube. So, that's it for today's guys. Thank you!
Good day, ma'am. I am Rose Milasa. Today I will discuss what is conic sections and analytic geometry. So, conic sections and analytic geometry are two related topics in mathematics. Conic sections are the curves obtained by intersecting a right circular cone with a plane at different angles, while analytic geometry is the study of geometric shapes and figures using algebraic equations and coordinates. In analytic geometry, conic sections can be represented by the second-degree equations of the form. This is the second-degree equations of form ax raised to 2 plus bxy plus cy raised to 2 plus dx plus ey plus f is equals to 0. So this is the second degree equations of the form in the analytic geometry. While the A, B, C, D, E, F are constants. The shape and properties of the conic section depend on the values of these constants and the angle of the plane with the cone. So there are 4 types of conic sections. They are circle, ellipse, parabola, and hyperbola. So each of them has a focus or foci, which is fixed points or point on the conic section, and directrix, which is a fixed line that is perpendicular to the axis of the conic sections. So the eccentricity of a conic section is the ratio of the distance from any point on the curve to the focus and the distance from the same point to the directrix. The eccentricity determines how much the conic section deviates from being circular. The circle has an eccentricity of 0. So the circle have eccentricity of 0, while the parabola has an eccentricity of 1. The circle has eccentricity of 0, while the parabola has 1 eccentricity. The ellipse has eccentricity between 0 and 1. And the hyperbola has an eccentricity greater than 1. So we should always remember that a circle has eccentricity of 0, the parabola has an eccentricity of 1, and the ellipse has an eccentricity between 0 and 1, and the hyperbola has an eccentricity greater than 1. So, the equation of a circle with center and radius is H and K, where the radius are R. So this is the equation, and this is the radius. So it could be x is minus h raised to 2 plus y minus k raised to 2 equals r raised to 2. So this is the equation, while r is the radius. In the ellipse equation is, so ellipse has a major axis of length and a minor axis of length. So the major axis of length is 2a, and the minor axis of length is 2b. And the formula, equation is x minus h raised to 2 over a raised to 2 plus y minus k raised to 2 over b raised to 2 is equals to 1. Since the eccentricity of ellipse is 1, the equation has 1 at the end. And the parabola equation is, the parabola has a focus of h, k plus p is that it could result to x minus h raised to 2 is equals to 4p y minus k, where p is the distance from the vertex to the focus and the directrix. Or the y-intercept is 17/3. And this one is the y-intercept. So the equation of the line in slope-intercept form is y is equals to mx plus b, where m is the slope and b is the y-intercept. So we need to substitute the values we found. So we get y is equals to negative 4 third x plus 17 third. As the equation of the line, this is the result after we substitute the values we found. So the second problem is we need to find the center and radius of the circle, whose equation is x minus 2 raised to 2 plus y plus 3 raised to 2 is equals to 25. Using this equation, we can find the center and radius of the circle. So the equation of a circle with center is h and k. and the radius is r. So the solution or equation it would be x minus h raised to 2 plus y minus k raised to 2 is equals to r raised to 2. So the r is the reduced. So comparing this with the given equation, we can see that h is equals to 2 and k is equals to negative 3 and r is equals to 25. Therefore, the center of a circle is 2 and negative 3 and the radius of a circle is square root of 25 is equals to 5. This is the uh, center of a circle. Radius of a circle. And this is the center of a circle. This is the radius and this is the center of a circle. 2 and negative 3. That's all I can discuss. Thank you.
Good day, today we will talk about the fractal's geometry. A geometric shape with intricate structure on arbitrarily small scales is known as a fractal in mathematics. Typically, its fractal dimension strictly exceeds the topological dimension. Numerous fractals exhibit similarities across different scales, as demonstrated by the progressively larger Mandelbrot set. The basic geometric shapes of classical or Euclidean geometry, the square, circle, sphere, and so on, are not the same as fractals. Moreover, an infinite pattern is called a fractal. Fractals are infinitely complex patterns with scale-invariant self-similarity. They are made by continuously iterating through a basic process in a feedback loop. Fractals are pictures of dynamic systems, the visual presentations of chaos, driven by recursion. So to conclude, it is a never-ending patterns on any scale on any level of zoom look roughly the same are called fractals. So let me give you an example. Fractal snowflakes. We've all heard that every snowflake is unique, and one of the contributing factors to the uniqueness of snowflakes is that they form in fractal patterns, which can allow for incredible amounts of detail and also variation. In the case of ice crystal formations, the starting point of the fractal is in the center and the shape expands outwards in all directions. As the crystal expands, the fractal structures are formed in each direction. Each iteration of the shape gets smaller and more detailed, which also contributes to the overall complexity of the shape. Fractal lightning and electricity. If you've ever watched a lightning storm, you're getting a front row show to one of nature's most powerful displays of fractals. When electricity passes through a medium that does not conduct electricity, well, like air, the pattern that is created becomes fractal. The reason this phenomenon forms is because of how the electricity interacts with the air. As the current passes through the air, it becomes superheated. Superheating of the air changes its electrical conductivity and allows the current to fragment out. This process repeats for each level of fragmentation and soon you get a fractal. You'll notice that if you invert an image of a lightning strike or electrical discharge, you'll see great resemblance to a tree. This is because both are fractals.